which is really awesome. It removes a lot of human error. It's repeatable. It's easy to deploy. It allows you to treat infrastructure commutably, and all these things are handy. Drilling down into those, I guess, is beyond the scope of this talk. Some of the things that we, as a DevOps team at Toro, are trying to do for our developers is roll a self-service style methodology of deploying their infrastructure. So we want to let our developers have basically full-on God mode to their individual isolated development networks where they can deploy whatever they need, but we don't want all of our developers to have to become Terraform experts necessarily. We want them to be able to go and log into a UI or feed parameters into a API that just kind of kicks off jobs in the pipeline. Deploys the infrastructure they need to push their code, to test it, to build it up, QA, those kinds of things. And so we're kind of, I guess, in the beginning of those plans, just playing with it more than anything, really. So that's kind of what direction we're heading with that as an org. Yeah, I guess, so I'm an engineer, so I'm not going to do a whole lot of talking, but I would like to get right into the demo, and we'll just kind of roll. I'm going to roll a cluster. It's not actually going to be serving anything. I'm not going to go to a UI or anything like that. I'm just going to roll infrastructure into VPC in the AWS cloud environment. So give me a few minutes to pull that up, and we'll kind of talk through it.
Rice on it. It's for God's sake.
All right. Let's see if I can zoom in on this a little bit. You guys probably can't see that very well, huh? All right.
In the terminal, we're holding Control Plus class of that? It doesn't. Okay. You know, also they use Bluetooth.
It should be Control Shift Plus. Do Control Shift Plus. There's an Ubuntu.
Yeah, okay, cool. I'm Windows, so like, that throws me off. But he's using Vim. Vim's a text editor, right?
Ubuntu is the OS.
Vim, V-I-M.
Vim. Yeah, Vim is the text editor.
Okay. And so he's got a, he's like, maybe a YAML file? No, maybe?
Hey, guys, do you mind if I put my tripod right there?
Oh, before it.
All right.
Right ahead.
Appreciate it.
All right, sorry about that. Everyone can see that a little better, yeah? No?
Better, yeah.
All right, well, I think that might be as good as I'm going to be able to get it, so I'm just going to do my best to kind of explain it, and I apologize for that. This is just one thing I really didn't consider. So, all right, so here though we have the main TF file. All of these files kind of get treated like one master file, so I've mostly just broken out so it'd be a little bit easier to demonstrate. Usually I wouldn't have this many files in here. If I get down to needing to separate things, I'd do more like submodules and things like that, but this is easier to demo. Here I've kind of cheated. I used a module from the Terraform registry, which is pretty cool. It's got a whole bunch of pre-baked modules you can use to do things. This one just spins up a VPC and feeds it, your ranges for your subnets. So I figured we'd focus more on specific cluster resources and not necessarily the whole thing here. So in this file, I've got here at the top, I've specified a remote backend. It's an S3 bucket. It's just a place to store state. When Terraform creates your resources, it stores a state file, usually locally, but you can configure it to be done remotely, which makes it easier to work with teams and things like that. This way, so this is the file that Terraform looks at to know what resources it needs to destroy, modify, etc. It's nothing fancy there. So down here we have the AWS instance. Actually, this is an EC2 instance. You just specify it all right here. This variable, the instance type, or the count variable. This is just a fancy field that basically just creates a loop so that it can iterate over these resources and create multiples. This is handy for you to be able to scale out from one node to many nodes, or etc. So you have so you don't have to repeat yourself in code, which is nice. So I've commented this out because I didn't want to punch holes in the firewall to make this work remotely, but this is where you would specify provisioning configuration and things like that. It'll execute a remote script when you spin up an EC2 instance. So one thing that we don't really do a lot here is most of the configuration. We generally just do generic things here like set host names and stuff like that, because there are better tools for that. We usually leverage Puppet to do like service configurations and things like that. But this is an example of how you could turn this into a web server. So I'm going to Terraform apply this real quick so we can see in the AWS console the resources that it provisions. And yeah, we'll go through the steps there. Okay, so that'll take a few minutes while it's doing that. So Terraform's going to leverage in this case, I'm using the AWS provider. So Terraform is built in Go, and it's basically just a wrapper for whatever SDK for your cloud provider. So like I said, in this case, we're using AWS, and it's going to leverage your standard credential chain. So I've got my credentials configured in the AWS file and all that, so that it has my keys and everything. So it has all the permissions it needs. So it's gonna
Yeah, sure, go ahead.
So you mentioned that you're creating account activities. I'm
Yeah.
not super familiar with AWS, I'm more familiar with Google Cloud.
Okay.
Does it put these in any kind of group, or does it literally just spin up 3 new instances that are, for all intents and purposes, unrelated to each other?
Okay, so the question was, does this spin up the instances, put them in any kind of group? Is there any kind of relation between them? So it doesn't necessarily group, AWS doesn't necessarily group resources like that in the same way that, say, Azure does, where you can spin things up with a specific resource group. This will tag the resources. I've told it to put some tags I can filter on like that. You can name it. They will all share security group and things like that. But it's basically just how you group them in the module and things like that. In terms of AWS, it doesn't actually resource group them like that. All right, it looks like we got an error here, so give me a second.
I think Terraform spaces, right? Can't use tabs. I feel like I've run into several issues. Like my problem was that I used a tab instead of a space.
Or is it like YAML log where it's like, oh, that's one too many spaces? Or you put it in tabs where there should be spaces. I am
Tabs where
upset.
there should be- Yeah, I as a .NET developer, I do mainly tabs.
Yeah,
except
same.
if I'm in YAML, in which case I'm doing spaces. Except for that time I didn't. And
Way is whenever you get code
I'll
from,
never forget that time.
like you try to copy and paste it, and then something along the way, it's like, oh yeah, you need tabs there, right? That's what you need, tabs. And then I'm trying to troubleshoot, like, why it's not working? Oh yeah, because and that's like the thing where you try to highlight everything before the words, like, oh yeah, it shows up as one character, like one big old character, because that's a tab.
Yeah, I think there's a bunch of stuff online that you can just paste your code in there and it'll be like, it'll convert tabs to spaces.
That's cool.
Yeah, so that's what I've always done, because I can't,
I'm sure
I
there's
can
something
never
you build
find
into the
it.
IDE that's like spaces to tabs.
Mainly use Visual Studio.
Okay, so even though that failed, I have a cluster up here that I pre-rolled when I was practicing earlier. So we can just move into that. I think it just doesn't like it because the VPC already exists. So I could probably Terraform destroy and get rid of all that and then roll it all fresh and it would be fine. But for the purposes of moving on, we'll just jump to this part. So you can see here that we've rolled our 3 nodes, and by referencing the indices here, I was able to name them incrementally. And all this was specified in there. I don't know if you guys have ever tried to spin up EC2 instances, but this Terraform will actually provision the VPC, all the subnets, the security group, the DNS records, everything to make this work, and it's literally as simple as a Terraform apply. And it probably took 3 hours of casually hacking around to get that configuration set. And now if I need to make a change, I can easily redeploy those changes. So I wanted to demo that part, being able to easily change this infrastructure from the code and reapply. So what I'm going to do is go in here and hard code the VPC ID so that we can redeploy the cluster and not worry about all this error stuff.
Need some water. Yes, I did. My card.
Okay, so that should avoid that error. So now we can get into the fun bit. So we've got a deployed 3-node cluster that registers as targets for a load balancer currently. So what I'm going to add here is I'm going to open up the variable and just increment the counter so that it spins another instance, and then I'll show you first how it's not present in the target group or the cluster, and then after I roll it, we'll go back and see how it auto-updated all the different pieces of infrastructure. So I'm going to do all that up on the screen, and I'll try to talk while I'm doing it as much as possible, although holding the mic and trying to navigate the keyboard is a little awkward. Okay, problem solved. All right. All right, so, well, that's not cool. So Okay, so here, oh, that's just the VPC. So let me start with the nodes in the cluster here. All right, so we already saw we've got 0, 1, 2, and 3 here. So if we go down to the load balancer, which was also provisioned by, all of this was provisioned by this Terraform configuration. So here's the load balancer, and here's a listener. Okay. Okay, so it failed out earlier at the VPC ID, which I fixed by hard coding, and so it didn't actually add the to the target group. So when I roll it this time, it should fix that, which is actually kind of cool that we get to go through that because you can see how this all works. And I didn't get it everywhere, so bear with me.
Makes it a bit more but there's a lot of stuff that's black in it that can't be, it's a lot of iteration for like finding the drives to the instance, getting that sequence right. Those loops are hard to, those loops took us a really long time to figure out how to make them reliable. We haven't used public or we haven't used public that much before. Prior to me being in Toro, my network with just about 150 nodes. On my way everywhere. It doesn't have, it's like cobalt. It's like developing cobalt. You don't have
Yeah, that's definitely happier. I'm also struggling with this tiny keyboard. I usually have a full-on ergo and a whole bunch of custom key mappings, and that stuff is just messing with my flow here. So, oh, I know. So, all right. So let's hop over in the console here and see. We got this.
It's all it takes.
All right. So why is it not working now?
And then you have a test seat.
That's frustrating.
I'll get fancy with it. Run Docker, dash G for the template, one to basic, dash R, dash RM, dash IT, then dash, and then have a shell script that run, like install something. And then you have something
Well, all right. So that was a flop. I apologize. That stuff worked earlier. You know, that's how these things go sometimes. I guess we'll do Q&A. I guess. Does anybody have any questions? That might work better. I actually do have knowledge on this, and I do use it almost every day. I promise.
Have you had any issues with multiple being committed or like the Terraform plan, Terraform build, and apply with
Okay, so the question was, and I'm going to summarize it a little bit, was have we incurred or have we arrived in the issues with multiple people committing to the same Terraform configuration and having issues with state? So most of the way that we have done our experimentation with it so far has been in a whole lot of standalone repos that leverage like the open source Terraform modules. And so with it all being like a standalone repo, it's usually just a single engineer that's working on it. So we haven't encountered those problems necessarily, but the strategy that we have implemented in circumstances where that might be an issue is we will have, so we use a workflow similar to a development workflow, right, with any kind of code. So we'll have a master production branch that maps to a production workspace. And I can show you how to check out workspaces in Terraform here in a minute. But it'll map to a specific workspace, which is an isolated copy of this state file. So that'll be like your production master branch. And so we would have a development branch as well, and we would check out our feature branches off of it, merge those feature branches back in development, and then merge in and then version bump, just like you would with any source code. And you map all of those to their own state by using a workspace. And that'll avoid those kind of collision problems, where you might accidentally do a Terraform destroy or apply, and half your production infrastructure is now gone, right? Because it is dangerous in that sense, if you don't pay attention and be careful. So the command, it's actually really easy. So right now, I think in the production workspace.
It does have some protection against that too. Like I had to explain to a guy who's unfamiliar with Terraform in our company who was curious how it maintains state, how it knows when to create something. And what Terraform will do is it'll have an internal representation of state that will do a quick check to make sure that things are the way it expects. So if it tries to go modify something that no longer exists, it'll then realize, oh, I need to spin this back up. So it does have a little bit of fault tolerance there. Now, I don't know how that works in terms of multi-tenancy, but there is that, so that's useful.
So here I've listed the current workspaces. Right now I just have the default. Every single Terraform directory that you Terraform init will have the default workspace. I've created the production one, and if I wanted to create a new one, so with that command, Terraform workspace new dev, I just created a new dev workspace. And now if I had the matching branches in my GitHub repository, I could just check out that branch as well. And then it would be a completely separate set of code and also state. So I can do all my changes and experimenting here. Yeah, you would want to, so earlier I talked about the self-service infrastructure for the developers, and so this is the kind of thing you would want to leverage in a pipeline. If you've read or watched anything about Terraform Enterprise, it actually does all of that state management for you through the UI and the APIs. It's kind of a handy thing, but you can also roll your own tools for that. You just need a UI wrapper and source code management. So that kind of answer that.
Yeah, no, the user works, but enabling the users was the second part that I was going to ask was how do you ensure like all your users to be like self-service, have their own state, but the CI aspect?
Yeah, you control it through pipelines and some kind of gated check-in, like any kind of deployment tool like an Octopus deploy or something like that can be used as a gated check-in that will ensure that the parameters that your Terraform modules rely on are actually populated and prevent people from deploying to the wrong environments and so on and so forth.
So for these workspaces, do you have to change the where you're storing state at all? Do any configuration in Terraform to say don't accidentally overwrite prod, or does it all just kind of magically work? You keep the same S3 bucket that your prod state is in.
Okay, so the question was, how does Terraform store the state files? Will you overwrite your prod state in your backend, right?
Yeah, for the
Is the
workspace
concern?
specifically.
Yeah, for the workspaces. Okay, so when you check out a workspace, it actually creates a separate file structure for it, so it stores it separately. With this case, I've got the single remote backend stored, so it all gets pushed to that same bucket. A better practice is probably to create separate buckets for environments, which you can have in your different isolated accounts or VPCs or however you, well, regions rather, because buckets aren't linked to VPCs, but however you want to do it, that's with AWS. There's also remote backends for all the cloud providers. You can use Blob Store in Azure and so on and so forth. But Terraform actually handles all of that for you, and then you can specify by leveraging, Terraform has like a built-in variable so you can reference the workspace name, so you can name all of your resources based on your workspace as well. So if you're in like your dev workspace and you deploy, it can be dev, node, name, etc. And you can do the same thing with your state too. It points to development, like workspace name dash bucket name, right? And so that's the way you can use different buckets to protect your workspaces and isolate them. And then that allows you to also more granularly control the permission sets as well. So nobody who doesn't need access to your production state can even see it, let alone modify it.
So I know that you talked a little bit about infrastructure as code being what you're demonstrating. It's my understanding that Terraform also has implications for like platform as code, such as Kubernetes, or software as code, such as like any of the setting up a server for Google Hangouts or something like that.
Okay.
Have you all worked with that at all, or platform as code?
So I think you're asking about the various different providers, right? Because it can deploy to Docker and things like that, and we haven't worked with that.
Okay.
Okay, but
So the question was, have we worked with any platform as code using Terraform? I believe the way that's handled is with different providers, because you can use Docker as a provider, so you can deploy these same kinds of infrastructure locally with your Docker daemon on your individual machine. And it's the same syntax, you just swap out a provider. And then those resources, which is all really well documented, those resources have their own fields and parameters and all that, but you can easily swap that out. Some of the work that I haven't personally done, but some of our more senior devs who are also playing with Terraform, we're working to kind of abstract away the provider layer a little bit so that we can just feed it IP ranges and rules and things like that, and the code knows which, like, it can deploy to any platform. For example, it can deploy to Azure or AWS or GCP or VMware or Docker or whatever, and it'll just leverage different middleware modules for that. So it's kind of cool. But no, I haven't played with that specifically.
Okay.
Anything?
Earlier, you mentioned how governing the configuration of the OSs and the VMs would be better done in a different tool like Puppet or Chef. Why and where is that line out? Which one's better than the other?
that's a good question.
All right, so the question was regarding what I had mentioned earlier about using a configuration management tool to do things like configure your services and such, and where the line is. So what we usually try to do is we'll actually leverage Packer to do all of like our patching and all of our package installs and things like that. And you'll build in layers similar to kind of like what Docker does. So you have your OS layer and you patch that, and then you have like your, say, you'll have like a Go layer or a Java layer or something like that, and you patch all of that. And of course those will be versioned and things. And then just in layers, and it'll keep going, then you'll have your application layer on top of that. So we try to do all that there so that the build's in layers so it doesn't slow down any individual build, because you don't want to be building your application and then have to do all your OS patching and all your language patching and all that kind of stuff, and then also all your dependencies and everything. It's slow build. So you build those layers and it can all just happen automatically. Now we're not there yet, but we're headed there. Hopefully. So we do that there. So that's a better tool for that. And with Terraform, you literally just specify the configuration of it. So I want a web server cluster, right, like this here. And then once you get to those provisioners where I had commented out for example purposes, that's where you'll want your Puppet to do all the heavy lifting. Like, okay, I've got a default Elasticsearch cluster. Now I want this to be my Elasticsearch cluster. So I'm going to feed it all the custom configurations for this specific cluster. So you can do all that here, but it's a bunch of bash scripts. So it works, but it's a little hacky, it's not elegant, there are better tools for it. So we leverage Puppet for that whenever it starts to get muddy. And if you start playing with this, you'll know exactly when you hit that mark, because it'll feel hacky, it'll be hard to do. You'll know. And it's basically, you can set host names. Have you rolled a lot of things in the cloud, or?
A few things with the built-in tool, nothing with like Ansible or this or anything.
So all the cloud VMs have user data or like a script that executes at startup one time. Anything you would normally do in that is pretty safe to do in your Terraform, right? Because it's usually pretty clean. Once you get into things like that, you want your service to be configured. You need to make this cluster aware of all the other nodes of it and tweak the configuration files and make sure that it has replication and things like that. That's when it's time to, lean on a configuration management tool. And since these are immutable, we don't leverage those tools to continuously push that configuration. We only do, it's like a handover, more or less. So it's like we roll the infrastructure, slap the configuration on it, and then it is that state until it dies.